There's a new component available in the latest ContinuuMini release that will be part of the next official Continuum and ContinuuMini release, the Signal Multiplier. This is available on each of the 5 oscillator filter options. Let's talk about what this new function is doing and how it adds a new component of sound creation to the EaganMatrix. To start out, let's just create our standard sine wave. We'll use a fixed frequency component here on our first oscillator of 440 Hz. Remember, this is in kilohertz, so I'll put in 0.44. And now, because this is fixed, no matter where I press on the fingerboard, 440 Hz will come out. I'll just use the standard Z function. That's Z pressure in a squared function going from 0 to 1. This is oscillator 1, so I'll put that on the SL-SR1 outputs. And now let's bring up our spectrum analyzer and see what happens if I play. Now I pressed all the way down, and you can see I get my sine tone at, here you can see 100, 200, 300, 440 Hz. But there's also this secondary component. Now if you have a Continuum or ContinuuMini and you press all the way to the bottom of the finger bed, you can get some harmonic distortion. Now you can see if I press lightly, I can get just a sinusoid coming out if I don't overmodulate on the fingerboard. What we'll do in our preset now then is, instead of using Z, let me create another formula A, and on Z I will just set that to a lower maximum value, say of 0.25, and I'll put that on the output. And now I shouldn't see that extra harmonic component if I go back and play. Alright, that's what we want. Let's add another tone. We have 440. Let's add the octave beneath that, 220 Hz, 0.22, and I'll send that out using the same A function on the second oscillator. And now I should see 2 tones coming out. There, obviously, I have my 440, and now I have 100, 220 as well. Now, what we want to do is create a signal multiplier, and that will have 2 inputs, audio input 1 and audio input 2. And you can think of this as a carrier and a modulator if you like, or 2 frequencies that are just going to modulate each other. The point is, when I take 2 sine waves and I multiply them, the result is going to be the sum and the difference of those 2, but the original tones will not be in the mix unless, of course, the sum or the difference is one of the 2 original tones. That'll be the case here, because if I add 440 and 220, I'm going to have 1 tone coming out at 660 Hz, and 440 minus 220, the other tone, the difference tone, will come out at 220 Hz, the same as one of my tones. So let's remove the outputs on those oscillators, and instead we're going to send oscillator 1 into the multiplier, send the full unity amount, and we'll send oscillator 2 into the multiplier on the second input. Now I'll output on the third oscillator, or in this case the multiplier, using my same formula so I don't create that harmonic distortion, and let's see what happens. You can hear it's not quite an octave anymore. What we have is 100, 220 Hz, our difference tone, and 1, 2, 3, 4, 5, 6, 660 Hz, our summation tone. Why can this be a really good addition to the EaganMatrix sonic possibilities? Well, if I have 2 audio inputs and I get the difference and the sum of those, in effect, I'll be able to create ring modulation-like effects now, and that I couldn't do easily before. Let's do something a little different. I don't have to have one of these tones in the audio range. I could say put this as 30 Hz, or something really low. Now I'm going to have 440 plus 30, so I should have a tone of 470 Hz coming out, and also 440 minus 30, which would be 410. Those 2 tones are not really harmonically related, so this should be quite a different sound. You can hear there I have the 2 tones close together, 1, 2, 3, 410 Hz and 470 Hz. And I think you can start to see, based on the carrier and the modulator, you can get some very interesting sounds come out like this. Now we're rather limited if we're just going to use fixed sine tones, so let's do this a little differently. Let's take one component which tracks the X direction on the fingerboard. So this will be whatever tone I'm playing on the ContinuuMini in this case. And on this other one, let's make that a dynamic tone too. We'll make that the same tone, only let's multiply that by something that's not harmonically related, like say 1.43. So we'll create a formula and we'll try and create something 1.4, and here I can on the Y add another constant to that, 0.03. And now we'll take that formula and use it as a multiplier on X, and that will be the second waveform that's fed into my multiplier. Well, you can hear two tones are still coming out because I have two sine tones and I have a fixed relationship. Now, we've only been using sine tones, and those don't really have any complex harmonic content, so I'm not really taking full effect of this technique. Its real power comes when I start using waveforms with more complex harmonic spectra, and then when I start multiplying that against, say, a sine wave or some other audio input, I'm going to get a much more complex output because I'm going to have the sum and the difference of many harmonic components. Let's give that a shot. So instead of just using a sine tone, let me give a little more harmonic content to this. I'll set the spectral balance of this oscillator to 0.3. Let's turn off our multiplier. We'll turn on that oscillator and you can see what this does. I have a much more complex waveform now, and I'm going to take that, and what I'll do now is I'll turn back on my multiplier, and instead of just multiplying two waveforms of the same frequency, and what I'll do is I'll add a little bit of an offset like we did before with the multiplication, but now I'll just add, say, 50 hertz onto that second waveform that's already complex. And now when my multiplication occurs, with the sine wave in this case, I'm going to get a much more complex sound, one that you'll start hearing a ring modulation kind of effect. There, and we can see we have a much more complex structure going on here, and this becomes the basis for creating very complex modulations and some very strange sounds that you can create using this signal multiplier. There are a few presets that use this signal multiplier in the new release. If you go to the synth category, Crossmod 1, 2, and 3 use it, as well as Zazipad at the bottom. Let's just take a look at Crossmod 1. Here you'll see we have two oscillators, 2 and 3, that are being fed into a multiplier, just like we did. This is a little more complex now. Let's consider oscillator 2, the carrier, and oscillator 3, the multiplier on that. What's being done here is you can see the spectral balance of both oscillators is set the same, but that is controlled by Y. So as I move from front to back, I can increase the harmonic complexity of the oscillators that are being fed into the multiplier. There's also a frequency multiplier on oscillator 3, which is controlled by barrel 1. So that will change the frequency as you change the barrel of that modulator. The multiplier itself, the carrier, is sent in with a unity volume, but the volume of the modulator can be changed with barrel 2 as you press on Z. Let's see what this sounds like. You can see very complex harmonic content going on here. Let's change the depth as I play now. There you can see. At the minimum value, we have a much simpler content, and as I increase, I increase the harmonic content of my output as I increase the volume of the modulator. There's also a little bit of convolution used on this preset as well. That's about as basic a use of this as you'll see. If we go to Crossmod 3, for example, you'll see that one has a lot more complexity. It's even using shape generators, and you're free to experiment on your own. Zazipad, again, even more complex. So exciting times for the Continuum community. We now have the ContinuuMini, and as you can see, Ed Lippold and Christoph are not content to just let the EaganMatrix and Continuum sound set remain static. They continue to add great features to this already amazing product.